Today we are going to go over series of consecutive integers. And by series, if you remember, we mean adding all the number in the sequence. So when we say series of consecutive integers, we're basically adding up consecutive integers. And to start off this section, let me tell you a little story about a mathematician named Gauss. Okay, so when Gauss was a student, here's Gauss, and here are his classmates. When Gauss was a student, the teacher gave them a very weird assignment. And by this time, they were only in elementary or middle school. And the teacher told them, add all the numbers from 1 to 100. And obviously, this is not an easy task, or at least it's going to take them a while to add all the numbers from 1 to 100, especially for an elementary or middle school student. And back then, they didn't have calculators, so the students were forced to add all the numbers from 1 to 100. But the teacher was very surprised when Gauss came up after just a few seconds, and he said that he knows the answer. And the answer is 5050. And the teacher was very surprised. That is, in fact, the right answer, 5050. So how did Gauss add all the numbers from 1 to 100 in such a short time? And that is exactly what we're looking at today. That is in fact, finding series of consecutive integers. So let's explore what Gauss did here to add up all the numbers from 1 to 100 in such a short time. So let's have a list from 1 all the way to 100. So let's have 97, 98, 99, and 100. And we have to add up all these numbers. Now, obviously, it's going to take a while if you just start adding 1 plus 2, and then 2, and then that plus 3, and then that plus 4. So what Gauss did was he paired up the numbers like this, the first number and the last number. So if you add up the first number and the last number, you will get 101. And then he did the same with the second number and the second to last number. If you do that, 2 plus 99, you'll also get 101. And for the third numbers, you'll also get 101. In fact, you'll get the same numbers every time you add this way towards the inside. Now, how many 101s are there going to be? Well, you can keep on adding this way until you hit 50. That is exactly halfway. Half of 100 is 50. Once you hit 50, you're going to add 50 with 51 on the other side. Okay, and in fact, that is also going to be 101. Okay, so you've done this 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. all the way until 50. So you've done this 50 times. Done this 50 times. So the answer for this would be 101 times 50, which is 5050. So that was the method that Gauss used to add a series of consecutive integers from 1 to 100. So now with that in mind, can we think of, or can we derive a formula that allows us to add any list of numbers? So any list of numbers from 1 to, say we want to add until 1000. Will we be able to do that? Well, we can use the same method as we did here. So let's explore that a little bit here. And instead of using a number, let's use n. So we're adding up 1 all the way until n. Okay, and then remember when we added up numbers until 100, it helped us when we wrote a few of the numbers that were before 100, like 98, 99, because we could see how they added up with the second and third numbers. So that's what we're going to do with n as well. So the number right before n is going to be n minus 1. And the number right before n minus 1 is going to be n minus 2. Okay, and then n minus 3, etc. So this is our list of numbers. And we're using n here to come up with a formula to generalize this. Now this is going to equal the sum of all numbers from 1 through n. If you remember our introduction to series section, the way to notate that is like this. This means sum. This means sum. And from when I equals 1 until n, that's what we're adding when we're from when I equals 1 until n, and then it's just I, because we're not doing anything to here. Okay, so this is the sum from 1 to n. Okay, and then we're going to write the same exact thing in the bottom, except we're going to write them in reverse order. And remember, we can do that in addition. We can say 2 plus 3 is the same as 3 plus 2 because addition is commutative. So on the bottom line here, I'm going to do the same thing as on the top, but I'm going to write n first. So I'm going in this order. That wasn't a straight arrow. In this order. Okay, so n and then n minus 1. You'll see why I'm writing like this. N minus 2, dot, 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 and then 3 plus 2 plus 1. And then this also is the same thing as the top, is when I equals 1 until n. Okay, so this is sum of I for 1 plus 2 plus 3 plus 4 until n. All right, oops. Now we have two of the same things, and let's add this vertically like this. So let's add 1 with n, 2 with n minus 1, 3 with n minus 2, and then adding all the middle numbers as well, and then n minus 2 and 3, n minus 1 and 2, and n and 1. And if you see, each of these sum is going to exactly equal n plus 1, right? This was 1 plus n, which is n plus 1. The second part is going to be 2 plus n minus 1. The 2 and the negative 1 are going to add up to positive 1, so that's also going to be n plus 1. The 3 and the negative 2 are going to add to positive 1 as well, so that's also going to be n plus 1. And again, here negative 2 and 3 are going to add to positive 1, n plus 1. Here the negative 1 and 2 are going to add to positive 1, n plus 1. And then n plus 1 is n plus 1. All right, so this now is in fact, we've added the two sums together. So it's actually the sum of the numbers from 1 to n, but it's actually this times 2 because we've added this by itself. What we have here is this times 2. Now, how about on this side? Can we simplify this side? How many n plus 1s do we have? Well, if you see, this column here corresponds to this n plus 1. This column here corresponds to this n plus 1. This column here corresponds to this n plus 1. This one to this one, and this one to this one, this one's to this one. How many columns do we have? Well, we have 1, 2, 3, all the way until n, right? So we have n columns. N columns, meaning there are exactly n plus 1s. Right? We have n plus 1s. So this side on the left is going to simplify to n times n plus 1. Right? We went from 1 until n, so there are n plus 1s on this side. And that in fact equals 2 times, right? I'm just writing the same thing as here. Right? 2 times the summation from I equals 1 to n of I. Okay, now the reason we're doing this is to find this. What is the formula for this? That's the whole reason we're doing this. So we're solving for this part now. And to do that, we just divide by 2 because there's a 2 being multiplied here. So if you divide 2 on both sides, the 2's are going to cancel here. So the summation is going to equal n times n plus 1 over 2. And this, in fact, is the formula, is the general formula we can use to find the sum of numbers from 1 to any number. All right, so let's try a few examples using this formula. Let's say we want to add all the numbers. We want to add all the numbers from 1 to 70. Okay, so the way to write that using this summation notation is we want to add all the numbers from when I equals 1 until 70 of just I. Okay, and that is going to equal, so the n is 70 now. So that's going to equal 70 times 70 plus 1 divided by 2. Just going to be 70 times 71 over 2. The 2 will cancel with the 70, so that's going to be 35. And that's going to be 71 times 35. Right? And then we get 2,485. So because we have a formula, we can add up numbers really quickly now. And using this formula, we were able to add all the numbers from 1 to 70. And this one makes sense because when we added 1 to 100, remember, it was 5,050. All right, so this should be less than 5,050. Let's try one more example. All right, let's try to add all the numbers from 1 to 500. 1 to 500. Okay, so again, the way to notate that is the summation from I equals 1 to 500 of just I. And that is going to equal 500 times 501 divided by 2. Sorry, I should have written 500 plus 1 over here. I did 2 steps in my head. Okay, and then that's going to be 500 times 501 over 2. The 2 cancels with the 500, 250. Right, so we have 501 times 250, and that in fact equals, oops, zero, 52521, 125,250. Right, so we can use this formula to find the summation of any numbers or from 1 to any number.